Now what we're doing first is volume. So this, again, we're going back to the 6th grade book for volume and surface area. This is the last chapter of the 6th grade book, which we're going to do this for a couple weeks. I did some of the 7th grade book first because it's actually easier than this, but this 6th grade chapter 9 is a little bit more complicated, so I wanted to go back to this a little later after we get the hang of this distance learning thing. So I think we're good now. So what we're doing for volume, I know a lot of you have done volume or probably remember it from science, but we're just going to do a quick review of some easy volume, and then we'll get to more difficult volume. And all volume is, as this definition says, is a measurement of the size of a 3-dimensional region enclosed within an object. Volume is a 1 by 1 by 1 unit cubes that fit inside a solid. So it's filling something with cubes. And when I say cubes, the measurement, the way you mark this measurement is different. Yeah, go get paper and pencil. I'll just sort of start slowly right now if you don't have anything. Sorry, I forgot to say that. So if you don't have paper and pencil, I definitely would have it for this because you're going to have a little calculating to do. And a calculator might help you too. So if you have your phone or a side calculator, that would be good. Yes, so the formula for volume is length times width times height. That is right. Or base times width times height. Either is good because volume is always a 3-dimensional item or object. So it's something that can be filled, like a gallon of milk has volume. The milk would be the part that represents the volume. So that's what we're going to do first. So a couple little problems on volume first, and then we'll get to surface area, which is a little bit more involved. So let me go, I'm going to go back to this because I have to share this document. And what I did is I chose a couple problems from lesson 911. So this is the ebook. So for your homework, part of your homework will be from lesson 911, part of it from 912, and part of it from 127 in the 7th grade book. So it's sort of jumping around a little. And I did put a couple problems on your homework that are just extra problems I made to help break down finding the surface area of an object. But this one here, let's look at this and see if you guys could help out. This is an easy problem. This is definitely a lower level volume problem. What it says here is that Jeremiah built a box that was 5 inches long by 6 inches wide by 7 inches high. He started filling it with 1-inch cubes. So when you see that symbol that stands for inches, he quickly realized that he did not have nearly enough cubes to fill the box. Can he still figure out how many cubes it would hold? So what you would do for this is you're going to use that volume formula of length times width times height, or base times width times height, either way, across the front, across the side, and then the side, the length of it, and then you can look at the height. So when you do those 3 measurements together by multiplying, I want a labeled answer though. I see a label for one of them. Now think about what they're telling you. They're saying it's 5 inches by 6 inches by 7 inches. So don't forget your labels. There's actually 2 labels, just like area. You have inches and you have something else. So type in what you think it would be. I'm going to give you a few more seconds and I'm going to go over what you all typed in. Also, I'm going to get my drawing tool out.
Wait.
Oh, it's not going to let me draw on this. Another minute. So I'm going to, what do I have to do really quick is I have to go to this other shared screen because it's not letting me draw on it. There we go. So what I saw people typing a few different things. I saw 210 cubed to the third power, or to the third power, 210 inches squared, 210 inches squared, 210. Anybody else before I show you what you should be thinking with this? Okay, I see squared. Now for this one, it was 210 because you had 7 times 5 times 6. So I agree with the 210. This is fun. Okay, but the part that I agree with is this part, the 210. But as far as the label, it is inches, but it's not squared. And now some of you said cubed, which is better, but don't forget the inches part, because since they gave you a label, you have to use it. Now you could write the word cubed, because I know it's, unless you're doing what I'm doing, drawing this on, it's hard to show it. It is cubed, or to the third power, or you could write inches cubed, because when you're doing volume, you're filling a 3-dimensional object. So that's why it's cubed. So the label is going to be different. 3 stand for cubed, so that's how you would label it. So keep that in mind. That's the one thing you have to remember for volume, is that the label is cubed, not squared. Surface area is going to be squared, which we're going to do in a little bit. Volume is cubed. So the next problem, it would also be cubed, not squared. So keep that in mind. So that's how you would do that one. Now this one is more tricky. Like simple volume, like the one you just did, it's very straightforward. It's just length times width times height. You multiply it, you label it, you're done. Now 9-7 is more difficult. Oh, said don't show an answer, and I was about to show you guys the answer. So for this one, this is more involved. Now think about what they're showing you in the picture. They're showing you a little cube, but it's not a 1 by 1 by 1 cube. It's only a 1/2 by a 1/2 by a 1/2 inch cube, which makes a difference, because the formula for finding volume is 1 times 1 times 1, not 1/2 times 1/2 times 1/2. So that little cube down there is actually only what? If you, people that have calculators, if you find the volume, like if you have a cube that's 1 times 1 times 1, like the length is 1 inch, the width is 1 inch, and the height is 1 inch. If it's 1 by 1 by 1, that means the volume of a 1 inch cube is 1 inch cubed squared. I mean cubed. 1 cubes, 1 inch cubed. So, but this one's a 1/2 by 1/2 by 1/2. So if you have a calculator available, you don't have to put the fraction, just make the decimal. Do a 1/2 times a 1/2 times a 1/2. What do you get when you do 1/2 times 1/2 times 1/2? Because that little cube is not worth 1 inch cube. So if you have a calculator, put that in your calculator, 1/2 times 1/2 times 1/2. Good, and I see people typing. Yeah, if you, that little cube is only worth 125,000 inches cubed, because it's smaller than a 1 inch cube. So it has a smaller volume. And that's important. So that affects how we do this problem. So think about what we have. We have a smaller cube. It's only 125,000 inches cubed instead of 1 inch cubed. So think about this problem now. Joaquin wants to find the volume of his cereal box, but he only has these cubes available. So he only has these 1/2 inch cubes available. He doesn't have regular 1 inch cubes available. He measured a box and found that it was 7.5 inches wide, 11 inches tall, and 2.5 inches thick. So what you would have done if we were in class, and I want you to think about on your own, how can I determine how many cubes are needed to fill this box in the easiest way possible? There's more than one way to do this problem. There's an easier way, and there's a very difficult way. But who could tell me what's an easy way to figure out the volume, which would tell me how many 1/2 inch cubes I need, since that's all he has available. So he has cubes that are smaller. So what would I do? I see division. It will still be multiplication. Now, Viv, you might be able to use division but it's going to be a lot more complicated. So I'm going to do this as easy as possible. So think about what they're telling you. You know that the box is 7.5 inches wide, 11 inches tall, and 2.5 inches thick. Now, if I had 1-inch cubes, I could just use those measurements and be done. But I have 1/2-inch cubes. So what do I have to do with those 3 numbers to be able to find how many 1/2-inch cubes are needed? What am I going to do to this number, and this number to be able to find how many of these are needed instead of 1-inch cubes? I see, make them decimals. I see some good guesses, but no one's there yet. I'll give you a clue. You can't use 7.5, 11, and 2.5. You have to do something to those numbers. And I don't mean change their form. I mean change their value. It's still multiplication. And we're not going to estimate. So no estimate, Colin. Good guess. Well, I want to make them whole numbers, but what numbers are they going to change to, Lucas? So 7.5 is going to become what? 11 is going to become what? I don't want to make 7.5. Well, let me give you one more clue. Stop typing for a minute. I don't want it to estimate. I want to find the exact number of cubes. So think about a 1/2-inch cube. A 1/2-inch cube is what part of 1 inch? If you think of a 1/2-inch cube, how much smaller is it than a 1-inch cube? It's half the size, right? It's half. Yeah. A 1/2-inch cube is half the size of a 1-inch cube if you look at one side of it. If you just look at one side of it, I'm not talking about the volume, just the side. Like if you look at the height of a 1/2-inch cube is half of the height of a 1-inch cube. So since that's half, think about how many more cubes I'll need to fill a box. If I had 1-inch cubes, I could just multiply these 3 numbers together. What do I have to do with all these numbers? Because I have to put how many more cubes in this box? Oh, I see times 2. Okay, think about what Kay's saying. I have to double the amount of cubes in the box. So what do I have to do first to my 7.5, 11, and 2.5 before I could find the volume? Not after, but before. I see times 2, good. So what do my numbers become? Instead of multiplying by 7.5, I'm gonna multiply by what? Let's do this step by step. 7.5 becomes what? If I double 7.5, I have what? Oh good, I see people typing 15. If I double 7.5, I have 15. So that's our new width. If I double 11, I have what? 22, there we go. And then finally, if I double 2.5, what do I have? 5, good. Now, if you have a calculator available, multiply those 3 numbers together and then type in your answer with the correct. Now for this, they're asking just how many cubes. They don't want to know the volume, so you just have to label your answer cubes. That's it, just cubes. Doesn't have to have a fancy label. So your answer, which I see a lot of people typing, would be 1,650. Now, if I was being picky with this, I would have you label it 1/2-inch cubes if I was being picky, because these aren't just regular cubes, they're smaller. So this would be a very precise label. Since their question was how many cubes would be needed to fill the box, it would be 1,650 1/2-inch cubes. So since we have smaller cubes, you would have to double the numbers first and then multiply. Now, Viv, you told me when you divided, you got the same number. So you divided 210 by 125 thousandths. Yes, that's the other way you could have done it. So what she said is that she took our answer from here 210 inches cubed. And since the volume of the individual cubes is this ½ inch cube, the volume of this is 125,000 inches cubed or cubic inches. If you take 210 and you divide it by this, that decimal number, you'll get this same answer. Good, Viv. That is another way. So if you understand that better, Vivi, that's a good way to do it. If you understand this way better, where since it's half, the height is half the size, you just have to double these numbers, do it that way. Both ways work. They're both correct. So Vivi, that's good too. Anybody have any questions on the way Vivi did it? Because it was the same information, we just had to, she took the volume of the little ½ inch cube and then she divided 210 by that volume. So that's basically what volume is. The most difficult type problems you'll see in 6th grade will be the one we just did, where you have a smaller cube than usual. But otherwise, volume's pretty straightforward. On your homework tonight, the volume questions will be very straightforward, or the homework due next week. It won't be difficult. It's going to be pretty straightforward for volume. So you see there, you see that I got the same answer.
Stop it.
Make sure your microphones are muted. I hear some feedback. So now, I'm going to show you this cardboard box, and I did talk about this before. So say I have this tissue box, and ignore the top, just imagine the whole thing's flat. Now with this, what I want you to do is think about what would happen if I flatten this. So if I cut this apart and flattened it, which I'll show you the flattened version of it, what would this look like? And now I know you can't draw me a picture, unfortunately, but what I want you to do is just tell me in words, if I flatten this box, who could just describe in words what it would look like? Now when I say describe in words, that means tell me what shapes it would be, and just describe in words the best you can about what the differences of the faces would be. Okay. So take a minute for that. Okay, I see tiny square things and rectangle things. Good. True. Okay. Let me show you what it would look like. So I know I showed a lot of you, if you were here last week, this. So basically, if I cover this box, see how in the video, one of the videos I'm sharing with you guys on the website, on the classroom, Google Classroom later, is something like this, where you see there's 2 yellow sides to this, there's 2 pinkish red sides, and then there's 2 green sides to this. So if you take a 3-dimensional object and you cut it apart, what's going to happen is that it's going to form a net. Okay, someone's trying to come in. Hold on a second. So what happens is that it forms a net. This is called a net. So what I want you to do is write the word net down, N-E-T, just like a fishing net, but not the same concept. This is called a net, N-E-T. So if you were to draw this net on your paper, basically this box here is called a rectangular prism. And when you make a rectangular prism flat, it looks like this. So you see there are 6 faces on it. Now that's important. There's 6 faces on it. There's for a rectangular prism, there's always 2 faces that match each other. See, the yellow 2 faces are the same area, the green faces are the same area, and then the pinkish red faces are the same area. So a net will always have, for a rectangular prism, it will have 6 different parts to it. Now that's important. Nets are flattened 3-dimensional objects, because on your homework, part of what you have to do and part of what you have to know for next year is knowing how to identify nets that match with the 3-dimensional shape. So this is the 3-dimensional rectangular prism, and then when I flatten that, that's the net of it. So that's important to know. I am going to show you a couple more nets, and oh, actually, not nets. I'm going to show you a couple more of these, and then think about, I'm going to show you, because I can't really have you draw it, but think about what A would look like flattened. And make sure the chat is what we're talking math, guys. Chat is for math, so I can answer questions. Think about what A would look like flattened, and think about what B would look like flattened. So think about that for a minute, and I will show you some other three-dimensional shapes that I have available here to show. So while you're thinking about this, what is this shape called? What is A called? Type in what's A called. It's the same as this. Not a box. Yeah, it's usually a 2-word name, most of them. Good, I saw one person type it. Not rectangle, careful. One of the faces would be a rectangle. Three-dimensional shapes usually have 2 words in them. So this would be called, I see more people typing it out, this is called a rectangular prism. Prisms have 2 bases. The top and bottom bases are the same. Now these could be the bases or these could be the bases, but a prism has 2 bases. So if I were to unfold A, it would look like this. It would look the same as here. Now make sure you don't say, yeah, rectangular prism would be that one. How about this one? Now this one's a little bit more challenging here. Now when you name a shape, a 3-dimensional object, you always name it by its base. So think about what the base is, the bottom of it, and then think about, is it a pyramid or a prism? So type in what you think that would be called for B, and then I'll help out. Now look at, it can't be a pyramid prism because it can't be both. It's either a prism or a pyramid. So it's either a blank prism or a blank pyramid. So you got to think about the first part of it. On the base, there is a 1, 2, 3, 4, 5, 6-sided shape at the base. Good. I see some people typing, well, I saw part of it. It's a hexagon. So a hexagonal what? Pyramid or prism? Hexagonal pyramid. Yes, this is called a pyramid. Now I don't have this shape at home, but I do have a square pyramid to show you why it's a pyramid. A pyramid is going to come to a point on one end. So notice at the very top here, it comes to a point. That makes it a pyramid. The base names the shape. So for the one on here on the paper, it's a hexagon. It's a pyramid because it only has one base. Prisms have 2 bases. So this one would be a square pyramid, the one I'm holding. This one here is a triangular pyramid because it comes to a point. So pyramids only have 1 base and they're named by the bases. And then notice that the sides are always, see how these faces are always triangles, but it's named by its base. So you have a triangular pyramid, you have a square pyramid, and B is called an hexagonal pyramid. If we were to lay these flat, this is what it would look like. So A would look like the one I showed you, like this. But B would look like this because it has triangles as the faces and the base is a hexagon. So knowing how to draw a net is important. On your homework, you're not drawing nets. You're just identifying what the net turns into. So for example, on your homework, if you're given this, you would tell me that if this was folded up, this would make a rectangular prism. And then on your homework, you would tell me if this was folded up, if you cut this out and fold it up, it would make a hexagonal pyramid. So those are things that you're going to have to be able to identify. And that's why I'm sending you these separate, is because if you have a printer, you could cut these out, these nets, and you could fold them up so you could see the 3-dimensional shape after you fold it up. So you could see like this is a square pyramid, and it's good to see these nets and see what they would look like when they're folded up. So I'm sending you those 4 papers with this lesson. So if you have a printer, you could print them out, or have, if mom or dad could print them up at work, that would be good too if you don't have a printer at home. I know the libraries are closed, but if you have the capability to do that, you can do that. It'll help you see them better. Now, let's look at these. Let's start with net A. Take a minute, don't type in all of them at once. I just want you to type in what net A would be if I folded it up. What would the name of that be? I would accept 2 different names for net A. So you don't have to tell me how many faces or bases. I just want to know what shape, 3-dimensional shape it would make if you folded it up. Okay, now, Lucas, not a rectangle, be careful. We're thinking 3-dimensional. So I see a lot of you saying cube, which is 1 correct answer. So see, this is the same thing. It just looks different. Net A is a little different, but if you fold that up, it would be called a cube. What's the other thing you could call net A? What's another acceptable name for net A besides, not a Rubik's Cube. That's cute though. Think about it. Oh, good. I saw John type it in. Good, John. Rectangular prism. Yes, because remember, squares are rectangles. So you could call net A simply a cube, which is the easiest name, or you can call it a rectangular prism. So the net A is a cube or rectangular prism. How about net B? Type in what you think you'd call net B. Now it's a little stretched out, and I'll give you a clue. Well, I don't want to give you too much of a clue. I'll show you the shape it makes after it's done. It's a little bit stretched out. Think about 2 names, a blank blank. Okay. Oh, I see square pyramid, I see rhombus pyramid, and I know it looks like a rhombus. Think of it as a square on the bottom, and then type in what you think. It just, when I print this out, when I make this, it stretches it out a little bit. Not a kite. We're getting very creative here. You could call it a rectangular pyramid. Honestly, if it didn't look so stretched out, because on your ebook it looks a little bit more true to form. It is a square pyramid, but you could call it a rectangular pyramid or a square pyramid. Both would be correct. It just looks a little bit distorted in that picture. So square pyramid or rectangular pyramid is good. Remember, you don't name by the, you name by the base of it, this bottom part, not the sides. So these faces aren't the name of it, it's always the base. So rectangular pyramid or square pyramid is good. How about net C? What would you call that? That should be easy at this point. Done a lot of those. That's the most common one you'll see. Good, rectangular prism is correct. And then finally, net D. See all those triangles coming off of it? Looks like a star. That's a big clue. We already saw this one. So what would you call net D? So we have net C, rectangular prism. Net D, what is this called? Good. This is another hexagonal pyramid, again, because you have 1, 2, 3, 4, 5, 6 sides on the base. So that's the hexagon. And then you have the star pattern. Usually when you see the star pattern, that means if it's folded up, it will make a pyramid. Now this isn't a pentagonal, because pentagon would have 5. This one has 6. So just be careful on that. Just count the sides. Because that would make a difference. I'm going to show you one more. What is this one called? I'll show you the base. And then I'll show you the, what is this one called? What is this called? Base, base. There we go. I see people typing it now. Rectangle, octagon prism. That seems so difficult, Tommy. Let's make it simpler, Tommy. If these are the bases, these 2 bases, And these are the faces here. We name it by the bases. So the bases are hexagons again, but there's two. So that would be a hexagonal prism. This is a prism because it has two bases. It's a hexagonal prism. So instead of being a pyramid, it's a prism. I lied. Two more. What's this called? You know this. This is a one-word name. One word. And don't worry about spelling, I know. Spell check might catch it. Circle prism, that's creative. Cylinder, it's just a cylinder, just a cylinder. This is called the cylinder. And I did have a cone, but I didn't bring it home. One more. What's this called? Last one. Triangular prism is correct. Now be careful, sorry, trying to show it the best I can. This is the base. This is the other base. Trying to show it on my little screen I have the best I can. This is a triangular prism. So, and if you can't see it, you have the triangles as the bases. And since there's two bases, it would be called a prism. So this is a triangular prism. Now, Kay, be careful because trapezoid is a two-dimensional shape. These pyramids and prisms are three-dimensional. And again, if you can't see these well now, I'm going to have the video up later so you can look at these later. And I did attach another video that I didn't do that somebody else did that'll show all these shapes again. So if you want to see these again, look at the videos I'm going to post later. So that's what nets are. Now, finding the surface area, make sure you have paper because surface area isn't difficult as much as it's multi-stepped. So there's a lot of steps to finding surface area. So when you find the surface area, you have to find the area of every side. So basically, when I have this tissue box that I showed you, if I wanted to find the surface area of this tissue box, I would have to find the area of the red side, the green side, and the yellow side. And after I find the area of those three sides, I have to double the measurement. So in other words, if I find the surface area of the yellow side, why do I have to double that measurement? Yes, there's two bases. In a rectangular prism, there's two bases. So to find the area of this prism, I need this yellow face and this yellow face have the same area. So because of that, if I find the area of this face, and I find this face, and then I double it, I'll have both of these. Same with the red. I'll have to find the area of this face and then double it because I have two of those. And then the green, same thing. I find the area of this face and I double it because there's two of those. So I'm going to try my best to color code this. Now, if you're artistic, just the same as we're in class, you can draw this shape on your paper. If you're not, do your best of doing this. Now, I think sometimes making a net of this shape is easier, but try to draw something on your paper. Tommy, I'll talk about the colors too. I'll label the colors too. On your paper, I would just label these with the colors that I use. So I'm just going to make this red. I'm going to make the front of this red, and I'm going to write red here, Tommy. So this is red. And I'm making it red. So the front is red. It's a terrible D, but red. I'm going to make the front face red. I'm going to make the top face. Oh, that's a highlighter. That's not going to, oh no. Hold on, let me erase that. Oh, is that purple? Okay, so I'm going to make the top here purple. I'm just going to write purple, perp. Oh, how about just per? Oh no, that's like multicolored. What am I doing? Hold on. No. Let's try again. This is not cooperating with me. Okay, so let's make that, I don't even know, Galaxy pen. I have all these different pens. Oh, there we go. That's better. Let's make this blue. So I'm going to make the top of this blue. So the top face, or the two bases, I'll make blue. And then let me add one more pen. And then I'll make this side face, I'll call it, I'm going to make green. So I'm just labeling these with colors, because when I'm talking about this, I'll say the green, the blue, the red. Now, when we're figuring these out, we got to figure out how, we want to find the area of one of these faces. So the first thing I want to do is I want to find the area of the red face. So how would I find, and now this is simple, this is just area. So surface area is only difficult because you have lots of steps, but finding the area is easy. So what do I do to find the area of this front face, the red? What do I multiply? Good, I see people typing it, so I'm going to put what you're saying. So the red, you would do 6 times 7 equals 42. And now the thing you have to remember with surface area is that there's more there than you can see. So 6 times 7 equals 42 centimeters squared, but we have 2 red sides. So what do I have to do with that 42? I have to double it, not triple it, Viv, just double it. I want to double it because there's 2 red sides. So the area of these 2 sides or faces would be 84. Now I'm going to label my answer at the end. So don't worry, I'll put the label on the end. So the 2 red faces, which would be the front face here that you see and the back face that we cannot see, and that's the most difficult part of this, is that you cannot see that. So far, all I did was the 2 red faces. So if this was our picture, I've only done this face and this face so far. That's it, nothing else. So that's the red. So I'm going to just put red here. These are the red faces. Now for the blue. Now think about for the blue, what do I have to multiply together to find the area of that blue top base? Think about what you need. You need this measurement and you need this measurement. Okay, I see a lot of people seeing it. Good. See, this is where you have to realize, well, which 2 measurements do I need? I don't need the height in this. I need the length and width. So correct. I see people picking the right ones. This would be, it's 7 times 3. And again, since there's 2 bases, the top blue and the bottom blue, we have to do the same thing we did with the red. We have to do 7 times 3 is 21. And then you're going to double that because there's 2 bases. And again, this is just area, only area, and that would be 42 centimeters squared for that. And then finally, the green. Think about what I need to find the area of the green faces. Type it in when you get it. A little late, Brendan. Think about what you need for the green. So for the green, you need this, and you need this. So see, be careful with this one, Lucas. Rethink what you're typing, Lucas. So you need this here, the height for the green side, and you need this width over here, the height and the width. So the height of the shape is at 6 centimeters, and the width is this side here, which would be 3 centimeters. So that would be 6 times 3, which is 18. And what do I do to the 18 then, guys? I double it. So finally, If I double that, I have 36 centimeters squared, not cubed. Remember, volume's cubed, area's squared. Whether it's surface area or regular area, it's always squared. So take a minute to add all of those up, and then I'll show you at the bottom the actual final answer, which is the final surface area of the whole shape. And while you're adding those up and typing in your answers, and make sure you label your answer too for area, not volume, surface area. So it's still the same way that we label regular area, that's how you label surface area. Let me review what I did. What I did is I labeled each color side a different color because it's going to have a different measurement. This isn't a cube, it's a rectangular prism, so there's going to be 3 different measurements here. We had the front face, which was 6 by 7, and that front face had a matching back face, front face, back face. And then we had the bases, the top and bottom, which were the bases, we made blue, and we did that 7 by 3, and we doubled it because there were 2 bases. And then we took the side faces, which we made green, and did 6 by 3 and doubled it to get 36. So when you add everything up and you label it appropriately, it would give you an answer, as I'm showing you down here. This is what you should have. That's all the work we did. So we had the front and back was 6 times 7 is 42 times 2 is 84. We had the 36, we had the 42, and the final area, you just add up all these sides and you get 162 centimeters squared, or centimeters with a little 2, not cubed. That's the big mistake I see. Don't confuse volume and surface area. So you see, surface area, the hardest part with surface area is doing the math as far as remembering all the sides are different, all the faces are different. It's not difficult math, it's just being able to see that you have to double the faces. The video that I attached to this lesson will really help you see this again, and they do explain it really well. Any questions on this problem? Because that's probably the most difficult thing you'll have to do. I picked very easy numbers just like this. I didn't pick crazy decimals or fractions. I just want you to understand the concept. I don't want to confuse you. So the numbers that I picked for the homework are very basic numbers. So it'll look a lot like this problem here that we just did. I recommend color coding if you're confused on this. If you have a printer, like I said, I recommend cutting out these shapes I'll send you, I'll attach to, and then forming the cubes or forming the rectangular prism. And at the top of each page, you'll see it tells you what shape it makes. So it will tell you if it's a square pyramid or rectangular prism or a triangular prism. So I gave you 4 different shapes if you want to print and fold. And this is usually a fun thing to do in class because we usually decorate these and then we print them. So you could show me maybe next week the ones you make if you're able to print those out. Any questions? I don't see anybody typing questions because you learned a lot today. You learned about nets, which is the flattened version of a 3-dimensional shape. So this is called a net. Because in 7th grade, you do higher level shapes. You're going to be finding area of shapes like this. Oh, so this is geometry. So you'll be doing higher level shapes next year. So this year it's just rectangular prisms. Sometimes you have square pyramids, which would be just finding the area of the triangles on the side and the area of the square. Looking at the shape as a net helps you find these.